Okay, good. So we go to the second part, drying theory. Why do we need to do drying, or what is the objective of drying? When we do drying, we remove water. We remove water means we reduce the water activity of the food. Then the activity of microorganisms is decreased. The enzymatical and chemical reaction rates also reduce. And because the microbial grow reduced, the chemical and biochemical reaction rates also reduce. So the cell life is extended. And that is the objective of drying. Okay, the first one. When we do dryings, then of course we also reduce the mass and the volume, so we reduce the cost for transportation, for storage, and also we provide consumer with convenient food. When we do drying, normally the texture of the food will be harder, and then also sometimes we improve sensorial quality of the product by drying. For a long process, some flavor we develop and then that would taste better. Okay, so we just look at several important parameters to review. The first one is water activity. Water activity is not the same as moisture content of a food. You look at chapter 2, food engineering in Vietnamese. There I explained very well what is difference between water activity and moisture content. Moisture content means the gram of water per 100 gram of what? Food. That is moisture content. But water activity is not the same. It represent what? If the water can be free or not free to evaporate. If the water in the food is free to evaporate, to become vapor, then we have high water activity. So it's determined like this: the vapor pressure of food divided by the vapor pressure of pure water. We measure at the same temperature. So the maximum value of water activity is 1 and the minimum is 0. So water activity ranges from 0 to 1. 1 is the water activity of what? Of pure water. Okay? I will just explain a little bit further here so you understand more, right? So what do we see? They measure like this. Here they put pure water in a closed chamber. Water will evaporate to the surrounding air, and after a while the vapor in the air will be in equilibrium with the water, and then you have a partial pressure of water vapor in the air, right? And then they do the same for food. Here they put food. Food contain not only water but other components, other dissolved components. Means those components love water, link with water, and then water become more difficult or easier to evaporate, more difficult to evaporate. So it's also evaporate but generate a vapor pressure of food, and this one is a pure water. This they measure at the same temperature, and then they use this to divide it to this one, then we have water activity. In food, if water is free, we normally have high water activity. If water is bound, we have low water activity. Bound means it's difficult to evaporate. Bound means it's not available for microorganisms to take it to grow, for enzymatical and chemical reaction to occur. So again, water activity can be defined as what? The availability of water for microorganisms to grow, for biochemical and chemical reaction to take place. Okay, so that is why when we reduce the water activity, we increase the cell life, right? We look at this figure. It's very nice figure. The maximum water activity is 1. cannot be higher, so we just remove that part of the chart. Anyway, before we go here, I will just give another example so you can just understand more. So if we have a soybean, dry soybean with 11% of moisture content, and if I have here milk powder with 7% of moisture content, this is milk powder, this is soybean. Which product will spoil first, do you think? Soybeans or milk powder will spoil first? Mean which one will have shorter shelf life? Huh? Soybeans? Why soybean? In this case, in this example, the milk powder will spoil faster. Why? We look at the moisture content. Milk powder has lower moisture content, but actually it has higher water activity. Because 11% of moisture in the soybean is actually strongly bound water. Strongly bound. And here, if the milk powder had 5% of moisture content, then it would be strongly bound. But now we have extra 2%, so it's quite free. This is water is quite free. And because we have some amount of free water, so the water activity is higher and the product spoil faster. Why I give this example? Water activity is a direct parameter determine the cell life, not moisture content. Because in some food you have high moisture content, but you have lower water activity. Water activity again is what? Availability of water for microorganisms to grow. If it's not available, they cannot take it. And the availability of water then now is represented by the capacity that water can evaporate. If it's free, if it's available, it can evaporate. Now we look at this figure again. Now see, maximum water activity is 1. When we do drying, we reduce the water activity, and then we inhibit what group of microorganism first? Bacteria, and then yeast, and then mold. Bacteria will not grow when the food is somehow dried. After that, the yeast, and then the mold. So when you look at dry food, if microorganisms, so which group normally grow? Mold. If you look at bread, you know bread is quite dry, but mold can grow. Dry fruit, dry beef, mold can grow. Because you look, mold is actually more tolerant to low water activity than the other two groups. And when you look at this figure, you also know that for dry fruit, you have to be careful with mold. Pay attention on mold. And then after that, yeast. Okay. The water activity by 6 is called critical water activity. By 6 is critical water activity. Because below that value, no microbial grow. Microorganism cannot grow. When you dry a product and you measure water activity and you see that it's below 0.6, then you are quite sure that your product will not be spoiled by microorganism. But it can be spoiled by other factors, of course. You can only be sure if you pack very well, okay? Because if you don't pack, what happens? Vapor from the air will be absorbed into the food, and then the water activity of the food will increase, and then the microorganism grow. When you buy dry fruit, for example, it look okay. You open the bag, you tear the bag, you eat a bit, you leave a bit behind. After several weeks, you look at and you see the mold grow. Because when you open the bag, food will uptake vapor from the air. We will explain this in some next slide. Right, and then when we lower the water activity, we already discussed the microbial changes. Now we look at other changes. For example, this represents for the non-enzymatic browning reaction, Maillard reaction, caramelization reaction, for example. It's the chemical reaction. And also represent for enzymatic reaction, enzyme activity. When we reduce water activity, it's somehow like this. When we reduce water activity, we somehow increase the rate of the chain, but then we have a maximum, a peak, and then up. If we reduce further water activity, you reduce a lot the rate of this reaction. Why we have a maximum here, or why is somehow lower rate at higher water activity here? Because we have what we call dilution effect. Dilution effect because when food contain more water, it's become diluted and the reactants are far away from each other. They cannot meet each other easily to react fast. Okay, it's called dilution. Bởi vì nó bị pha loãng á, yeah, with more water. Okay, but then when you reduce further, and then the water is no more available for these changes, this reaction to take place. Now there is a chemical reaction. It's kind of strange. Oxidation of food. You see, oxidation of food, it will go like that, the same like that. You have a minimum value for the rate of this chemical reaction. Remember, oxidation of food is one of the critical chain that cause spoilage of food, limit the cell life of many food with more oils and fat. Okay, and then what do we see here? It's a bit strange because if you reduce further, you remove all water, the reaction rate of oxidation become very much faster. It will not stop, but it become even faster. Right. Why this happen? Water in the food, we just explain here a little bit. If you have a food component, this is a food component, okay? And you have first layer of water. A layer of one molecule of water is strongly bound to that food component, and this is called monolayer water. This water is strongly bound, okay? Right. And then after that monolayer, you have several layers outside of water, and this is called multilayer water. Several outside layer. So this water is somehow linked to the food component, but not strongly. And then further outside, what do you have? Further outside, you have free water. This is free water. The water is away from the food component. It's not linked to the food component. Free water. This water evaporates easily when we dry. And this water contribute a lot to the water activity. These are the three types of water in food component. And now we look back here. When we reduce the water activity up to this value somehow here, then we do not remove yet the monolayer. And the monolayer of water will protect the food component. This water is not available, but it's cover, it's protect the food away from the oxidation. But if you remove further, you do like this, means you remove all layer of water, and then the food component has a high exposure, là nó bị lộ ra đó, high exposure to oxygen and to vapor in the air. Oxygen can attack easily into the food component and can oxidize the food easily. So for oxidation, it's a bit strange behavior in relation to water activity. You see this often in fried and in roasted product. Roasted beans or peanuts, for example. Right, fried and roasted, and then after several days you eat again, you already feel the rancid flavor because of oxidation. When you roast it, you remove all kind of water, and then it's become oxidized very fast. Especially when they put roasted peanut in a transparent plastic bag and they hang under the sunlight when they sell in the shop, then it's become oxidized very good. Now we just review another terms, moisture content. This is different with water activity that we already discussed a bit. Moisture content, see again chapter 2, what is the difference with water activity. Now in drying we have other term of moisture content. We have equilibrium moisture content and we have free moisture content. What is equilibrium moisture content? It's a moisture content of a substance of food at equilibrium with a given partial pressure of the vapor. It is used to describe the final moisture content that will be reached during drying. So in drying, what is equilibrium moisture content? You dry up to the end point. You call that equilibrium moisture content. Free moisture content will be the moisture content that we remove by drying. So you take the total moisture content, this is total moisture content, subtract it to the equilibrium, mean the remaining moisture content, then you have the free, the one that evaporates when you do drying. And in drying, we also need to distinguish between moisture content on wet basis and on dry basis. What is moisture content wet basis? Mean the gram of water per 100 gram of food. This is based on wet basis, and dry basis mean gram of water per 100 can be 100 or a gram of dry matter the food. Okay, wet basis moisture content, the maximum is 100%. What food have 100% of moisture content? Pure water. Okay, pure water has 100% moisture content. But on the dry basis, the moisture content can be higher than 100%. Can be lower, can be higher. But on wet basis, it's never be higher. For example, fruit juice. Fruit juice have maybe like 15% of dry matter and 85% of moisture content on wet basis, like 15 gram of dry matter, 18 gram of water. What is the moisture content on wet basis? 85%. What is the dry matter content on dry basis? 85 divided by 15. So it's higher than the 100%.